Welcome to a lecture on effects of alloying elements in steel. So this is S. Karthikeyan, Assistant Professor, Department of Mechanical Engineering from Erode Engineering College. So first of all, we can see the purpose of alloying elements. So what is the purposes are here listed out. Here it is so increase in hardenability. So that is through making through an heating process. We can increase the hardenability. So that is related with the iron carbon equilibrium diagram. So from the level of austenite and perlite to a maximum temperature of 1536 Fahrenheit, so we can get a increase in hardenability of alloying elements. So in steel we can consider for alloying elements, so it is used for hardening purposes and all. So next one is to improve the strength at ordinary temperature. So next one is to improvise the mechanical properties either at a higher or lower temperature. So there is a refractory property which is enabled in that material. The refractory means to withstand the higher temperature. Refractoriness is added in the alloying elements also. So next one is improving toughness at any minimum hardness or strength level. So next to that we can see that increase in wear resistance. So it is not subjected to wear and tear. Okay. Then it is to improvise corrosion resistance. So next one is improvise the magnetic particles, magnetic properties. So the alloying elements which are used in the steel, which can improvise the following purposes. So next one is manganese. So what are the elements which are produced as effect of alloying elements in the steel? So first the product is manganese. So what are the benefits are the cheapest it is a cheapest alloying element. So then it is a deoxidizer. Then it is a weak carbide former. So the amount of manganese lies between 0.03 to 1%. So in this composition we can add up manganese towards the steel to improve the property of steel. So next one is to improve the hard working properties and increase the strength, toughness and hardenability. So manganese is unlimited solid solubility by alpha ion. So it has a unlimited solid solubility. So next to that it reduces the tendency of hard shortness or red shortness, brittle at high temperature. So when we go for high temperatures, there will be some brittleness. So brittleness that occurs in glasses and all. So next one is iron sulfate. It is a thin film, makes crack through and grain boundaries. So example 50 up to 50 mm. So manganese eliminates the formation of harmful iron sulfates. So manganese increases also the machinability. Special steel is known as Hadfield steel. Usually contains 12% of manganese. So it is used in high speed tools and steels. So next one is silicon, 0.05 and between 0.2%. And then silicon is used as a deoxidizer in the manufacturing of steel. So to remove the oxidizing content which is present in the steel, so it is used for manufacturing of steel. So mainly silicon is another alloying element which is used for manufacturing in the steel. So it is a carbide former. So next one is solid solubility of silicon in gamma ion is 2%. Then solid solubility in silicon in alpha ion is about 18.5%. So it varies about 16% about in solid solubility. So then next one is it improves the electrical properties and fatigue strength of the steel. So electrical properties means the conduction, convection and radiation properties. So basically it improves the conduction process. So apart from these three, so next one is it increases the strength of low alloy metal. Then 13% of silicon content in steel is very high corrosion resistance. So it helps as a anti-corrosion agent, and it is also used in chemical industries. So for manufacturing units of steel, so it is basically used in chemical industries also. So Hatfield silicon steel with less than 0.01 percentage of carbon is about and it is about 3% of silicon. So Hatfield silicon steel has excellent magnetic properties for use of cores and poles for electrical machineries. So it is also used for it is having a good magnetic property, so that it is used for electrical machineries and all. So next to that we can see after that silicon, so manganese silicon, we are seeing about chromium steels. So it provides stainless property to the steel. So the chromium coatings, it is generally used in two-wheeler vehicles handlebars, rim contents, so like that the chromium is there. So it will be it is a anti-corrosion agent, so it provides the stainless property to the steel. So it is soluble up to 13% in mm, gamma iron, and unlimitedly soluble in alpha ferrite. So ferrite is nothing but about ionic content. So it is also widely used in tool steels and in electrical plates. So it forms a simple carbide and complex carbides. So formation of simple and complex carbides are both are with the process of iron. So these carbides have high hardness and good wear resistance, as well as say. So actually, chromium plays a vital role in wear resisting. So after chromium coating through electroplating process, so the chromium is used widely in that electroplating process and all. So using of anode and cathode through electroplating process, we are using chromium to coat the metals. So next one it is hard and stable, and with the tool steel. So it improves the hardness. Hard hardness means resistance to softening at elevated temperature. So elevated means reasonable temperature. So a special type of chromium steel contains 1 percentage of carbon and 2 to 4% of chromium. Has a excellent magnetic properties, and it is used for permanent magnets. So the composition widely contains around 1% of carbon, and as well as 2 to 4% of chromium for a better magnetic property. So next to that we can see for molybdenum. So it is a strong carbide former. It has a limited solubility in gamma iron as well as alpha iron. It has a strong effect on hardenability. It improves the creep strength. It increases the hardness and the strength of the steel. So this element is mostly used in nickel and chromium. So the molybdenum is mainly used as a constituents in nickel as well as chromium. It is also used for wear resistance material. So it reduces temper brittleness in steel. So easier breakage can be avoided by adding molybdenum. So it gives additional strength to the steel. So in carburizing, it improves the wear resistance of the screw. So carburizing is nothing but adding carbon content into that steel through heating process. So and improves the toughness of the core. So next to that is vanadium. Vanadium makes steel strong and more ductile. So power deoxidizer and strong carbide former. So next to that, it inhibits grain growth. It has a marked effect on hardenability, yielding high mechanical properties on air cooling. So next to that, it is used for goodly used for marking tools. It is used in marking tools. It is used for manufacturing of shafts, springs, and gears and forged parts. So so it is used for power transmission tool protection. So mainly it is used. Vanadium is mainly used for improving the ductility, as well as to make the steel strong, as well as it is used for manufacturing of power transmission of elements. So next to that is titanium. So titanium, it is a light metal, so it is a superior for corrosion resistance as well as wear resistance. So which is provided in the chemical environment such as solution of chlorine and inorganic chloride solutions. So mainly it is used as a chemical industry, and it is a alpha and beta stabilizer. So it has a high strength and weight ratio, strength to weight ratio, and are particularly used in aircraft parts. So mainly aluminum as well as titanium is used for making manufacturing parts. So it is a light metal, so strength wise it is good. So low weight and high strength capacity, as like compared with aluminum, it is also a metal with the same property. Next to that is it has a closed pack hexagonal crystal structure. So it is observed in the metallurgical microscope. So we can identify that it has a closed packed hexagonal shape. So which is observed in the room temperature. So the alpha structure transforms the cubic beta at 8 and 2 degrees centigrade. So next to that is tungsten. So tungsten for alloying element, it is used for improvise the magnetic particles as well as the hardenability. So it is strong carbide former. So it possesses the softening of martensite on tempering. So it is widely used in tool steels. So next to that, finally it is stainless steel. So minimum value of chromium is about 11.5 percentage, 11 to 12 percentage around. So stainless steel is used for both corrosion as well as heat resisting application. So next to that, stainless steel identified as 3-number numerical system. So corrosion resisting property is due to thin, adherent and stable chromium oxide or nickel oxide flip. So next to that, corrosion resisting property is evident only when the chromium content exceeds about 10 percentage. So the microstructure is contains of 12 percentage of chromium, and the steel is ferrite and small carbide particles. So the three stages of or three groups of stainless steel are martensitic, then ferritic and austenitic. So these are the three types of stainless steel. So martenstic is they are having martensite structure. Chromium contains about 11 to 18 percentage, and carbon content is ranging from 0.1 to 1.5 percentage in that same composition of stainless steel. So already the chromium is added for higher corrosion resistance and wear resistance, and as well as for improving and the carbon is added for improving the strength of the steel. So type 410 and 416 are most popular alloy which is used for turbine blades and corrosion resistant castings. So it is used for turbine blades which is used in power plants and as well as in aircrafts. So the both metals are said to be as magnetic, and it has a low carbon content, so that it can be machined satisfactorily. So machinability, the ability of machining is somewhat easier in this martensic stainless steel. So the composition is given below. The carbon is about 0.1 to 1.5 percentage, and silicon is about 1 percentage, whereas manganese present is 1 percentage, and chromium is contained about 11 to 18 percentage. So next to that, it is what are the properties are. It can be cold worked without difficulty. So these type of steels have good toughness, good corrosion resistance, as I earlier said, with these chemicals also used in chemicals too. So then these steels are normally hardened by heating them up to transformation range from 1010 degrees Celsius and cooling in air. So sudden cooling is not possible. So temporary gradual cooling is through air is where the hardening can be increased. So then minimum time should be for this steel is given for decarburization and excessive grain growth. Next to that, tempering is done about in this steel is about 595 degrees Celsius. The higher temperature causes precipitation of carbides. This reduces the corrosion resistance, type 431 MSS is used. So it is used for manufacturing aircraft fittings, paper machinery parts, pumps and bolts. So as well as motors. So then type 501 and 502 is used for petroleum refining equipments such as heat exchangers, valve bodies, pump rings and all. So these components are manufactured from 501 and 502. 431 is used for making aircraft components. So next to that is ferritic stainless steel. So ferritic stainless steel is containing a carbon content of 0.08 to 0.12 percentage, and silicon is about 1 percentage. Then manganese is in addition to 1 to 1.5 percentage. Then chromium is for 14 to 27 percentage. So actually carbon is for enriching the strength of that element. So chromium is for corrosion resistance, manganese is also for strength, silicon is also for strength. So these composition is involved in ferritic stainless steel. So this ferrite structure helps in all melting points. Then this straight chromium stainless steel, it is approximately about 14 to 27 percentage of chromium. These steels are not hardened by the heat treatment because of maximum carbon which is present as 0.12 percentage. So the hardening is not required for this type of steels. So these are magnetic and can be used in as well as cold and hot working. So mainly here for the ferritic stainless steel, so there is no need of heat treatment. So next to that, it stabilizes chromium, vanadium and molybdenum and vanadium and silicon. So it can stabilize all the materials. They are good. They have good ductility, strength and toughness, and also good resistance to corrosion. So mainly these alloying elements is manufactured against the corrosion, and as well as to improve the strength and to reduce the weight ratio. So the weight ratio to the strength is considered everywhere. So these steels can be welded, forged and rolled, and as well as it can be machined. So what are the applications means? Deep drawn parts such as vessels, then chemical and food industries. It has a high corrosion resistance, corrosive effective, and as well as having high strength means. So they are using it for chemical and food industries. So it is also used in architectural and automotive trims. So the lining for petroleum industries. So heating elements such as furnaces. So interior decorative works. Then oil burner parts. So it is used in minor as well as in the major components of production. So the next to that is austenitic stainless steel. So it has a carbon composition of 0.03 to 0.15 percentage. Then silicon is added up to 1 to 2 percentage. Then nickel is added for 3.5 to 22 percentage. Then molybdenum is 2 to 10 percentage. Then chromium is around 16 to 27 percentage. The chromium used in all the alloying metals, it is around 16 to 27 percentage, in the range of 15 to 27. So in addition here nickel is added additionally for this austenitic stainless steel. So these are chromium nickel steel or chromium nickel and manganese steel. So these having austenitic structure, the total content of nickel and chromium is at least 23 percentage. So total composition must be not below 23 percentage. It can be used used in cold working as well as hot working process. These are shock resistant. They have a best higher temperature strength. So type 304 is improving for weldability, and it is used for greater tonnage. So then next to that, it has a low carbon content of 0.15 percentage, so that it is used for minimizing the formation of chromium carbide. So the chromium carbide is can reduce the corrosion resistance. They have non-magnetic. Then good ductility and cryogenic temperature is below 0 degree Celsius. Then the applications where it is used is aircraft industries, then chemical processing units, and some of the example is heat exchangers, then food processing industries, kettles and tanks, household equipments, cooking utensils, then dairy industries, milk canes, transportation industries, so trailers and railway cars. So Uh, these are all the applications which are used in austenitic stainless steel. Thank you.